Azure App Service is a fully managed platform for building, deploying, and scaling web apps. It supports multiple languages and frameworks, including .NET, Java, PHP, Node.js, and Python. The service provides built-in capabilities such as continuous integration, deployment, and scaling, making it an ideal choice for modern web applications. In this presentation, we will delve into configuring networking settings for an app service, a crucial aspect of ensuring secure and efficient communication between your app and other resources. Networking is a critical component of any web application. Properly configured networking settings ensure that your app can communicate securely and efficiently with other services, databases, and users. In Azure App Service, networking settings can be configured to control inbound and outbound traffic, secure connections, and integrate with other Azure services. Understanding these settings is essential for maintaining the performance, security, and reliability of your application. Virtual Network (VNet) integration allows your app service to access resources in your Azure Virtual Network. This is useful for scenarios where your app needs to connect to databases, storage accounts, or other services that are secured within a VNet. VNet integration provides a secure and private communication channel, reducing the risk of exposure to the public internet. To configure VNet integration, you need to ensure that your app service plan is in the standard, premium, or isolated tier. To configure VNet integration, navigate to your app service in the Azure portal. Under the Networking section, select VNet integration. Choose the VNet and subnet you want to integrate with. Ensure that the subnet has sufficient IP addresses available and that there are no Network Security Group (NSG) rules blocking the required traffic. Once configured, your app can securely communicate with resources in the VNet. This setup is particularly useful for accessing databases and other services that should not be exposed to the public internet. Private endpoint connections allow your app service to connect to Azure services over a private link, providing a secure and private connection. This eliminates exposure to the public internet and reduces the risk of data breaches. To set up a private endpoint, navigate to the Networking section of your app service and select Private Endpoint Connections. Create a new private endpoint, select the target resource, and configure the necessary settings. This setup ensures that traffic between your app service and the target resource remains within the Azure Backbone network. To configure a private endpoint, go to the Networking section of your app service and select Private Endpoint Connections. Click on Add to create a new private endpoint. Choose the resource you want to connect to, such as an Azure SQL database or a storage account. Configure the necessary settings, including the virtual network and subnet. Once the private endpoint is created, your app service will communicate with the target resource over a private link, enhancing security and reducing latency. Access restrictions allow you to define rules that control inbound traffic to your app service. These rules can be based on IP addresses, service tags, or virtual network subnets. By configuring access restrictions, you can limit access to your app to only trusted sources, enhancing security. To set up access restrictions, navigate to the Networking section of your app service and select Access Restrictions. Add rules to allow or deny traffic based on your requirements. This feature is particularly useful for preventing unauthorized access and protecting sensitive data. To configure access restrictions, go to the Networking section of your app service and select Access Restrictions. Click on Add Rule to create a new access restriction. Specify the name, action, allow or deny, priority, and the source, IP address, service tag, or virtual network subnet. You can also specify the HTTP headers to match. Once the rule is created, it will be applied to incoming traffic, ensuring that only authorized requests are allowed. This setup helps in securing your app by restricting access to trusted sources. Hybrid connections enable your app service to access on-premises resources securely. This feature is useful for scenarios where your app needs to connect to databases, APIs, or other services hosted in your on-premises environment. Hybrid connections use a relay service to establish a secure connection between your app service and the on-premises resource. To set up hybrid connections, you need to install the Hybrid Connection Manager on your on-premises server and configure the necessary settings in the Azure portal. To configure hybrid connections, navigate to the networking section of your app service and select Hybrid Connections. Click on Add Hybrid Connection and provide the necessary details, such as the name, endpoint hostname, and port. Install the Hybrid Connection Manager on your on-premises server and link it to your Azure subscription. Once configured, your app service can securely communicate with the on-premises resource. This setup is ideal for hybrid cloud scenarios where your app needs to interact with both cloud and on-premises services. Network security groups, NSGs, are used to control inbound and outbound traffic to resources in your Azure Virtual Network. By configuring NSGs, you can define rules that allow or deny traffic based on various criteria, such as source and destination IP addresses, ports, and protocols. NSGs are essential for securing your app service when it is integrated with a VNet. Ensure that your NSG rules do not block the necessary traffic required for your app to function correctly. Properly configured NSGs enhance the security and performance of your application. To configure NSGs for your app service, navigate to the networking section of your virtual network in the Azure portal. Select Network Security Groups and choose the NSG associated with the subnet your app service is integrated with. Add inbound and outbound rules to allow the necessary traffic. For example, you may need to allow traffic on port 443 for HTTPS communication. Ensure that your rules are specific and follow the principle of least privilege. Properly configured NSGs help in securing your app service by controlling the flow of traffic. Azure Application Gateway is a web traffic load balancer that enables you to manage traffic to your web applications. Integrating your app service with Application Gateway provides advanced routing capabilities, SSL termination, and Web Application Firewall (WAF) protection. This setup enhances the security, performance, and reliability of your application. To integrate with Application Gateway, you need to configure the backend pool, routing rules, and health probes. This integration is particularly useful for applications that require high availability and advanced security features. To configure Application Gateway for your app service, navigate to the Application Gateway resource in the Azure portal. Under the Backend Pools section, add your app service as a backend pool. Configure the necessary routing rules to direct traffic to your app service. Set up health probes to monitor the availability of your app. Additionally, you can enable the Web Application Firewall (WAF) to protect against common web vulnerabilities. This integration ensures that your app service benefits from advanced load balancing, security, and traffic management features. Service endpoints allow your app service to connect to Azure services, such as Azure SQL Database and Azure Storage, over the Azure Backbone Network. This setup provides a secure and optimized connection, reducing latency and improving performance. To configure service endpoints, navigate to the networking section of your virtual network and select Service Endpoints. Enable the necessary service endpoints for your subnet. Once configured, your app service will communicate with the target Azure services over a private and secure connection, enhancing security and performance. To configure service endpoints for your app service, go to the networking section of your virtual network in the Azure portal. Select Service Endpoints and choose the subnet your app service is integrated with. Enable the necessary service endpoints, such as Azure SQL Database or Azure Storage. Once configured, your app service will use the Azure Backbone Network to communicate with the target services. This setup ensures a secure and optimized connection, reducing latency and improving the overall performance of your application. DNS configuration is essential for ensuring that your app service can resolve domain names correctly. Azure provides several options for DNS configuration, including Azure DNS and custom DNS servers. Proper DNS configuration ensures that your app can access external resources and services without issues. To configure DNS settings, navigate to the networking section of your virtual network and select DNS servers. You can specify custom DNS servers or use Azure-provided DNS. Ensure that your DNS settings are correctly configured to avoid connectivity issues. To configure DNS settings for your app service, go to the networking section of your virtual network in the Azure portal. Select DNS servers and choose whether to use Azure-provided DNS or specify custom DNS servers. If you are using custom DNS servers, ensure that they are correctly configured and reachable from your virtual network. Proper DNS configuration is crucial for ensuring that your app service can resolve domain names and access external resources without issues. This setup helps in maintaining the connectivity and reliability of your application. In this presentation, we have explored various networking settings for Azure App Service, including VNet integration, private endpoints, access restrictions, hybrid connections, NSGs, application gateway, service endpoints, and DNS configuration. Properly configuring these settings is essential for ensuring the security, performance, and reliability of your application. Best practices include following the principle of least privilege, regularly reviewing and updating your network settings, and monitoring network traffic for any anomalies. By adhering to these best practices, you can maintain a secure and efficient networking environment for your app service.